Hello, everybody. Today in this video, we're going to review how to divide with whole numbers. So I'm going to start by putting my title up top. Again, I am going to put the date in, or at least the week that I am studying this in as well. And what I write down, you want to write down. Okay, you can always add to it. So I do recommend as you're going through the lecture notes and the videos, just a reminder, I'm going to remind you guys of this every once in a while. Pause the video, take a moment, catch up, make sure you understand the problem. And then if you need to fill in more details along the way, if there's things that you have forgotten, because we're kind of assuming that you have some basic understanding of whole numbers already, that you pause and you fill in those gaps. So write in those little notes for yourself or whatever helps you to get through the processes. So today we're going to be working on dividing whole numbers. And I'm going to start, of course, with just a couple definitions too. All right, so what is division? So division is the process of separating a quantity into equal parts. And that word equal is really important. So when we're dividing things, we're trying to divide usually a whole, in this case, object into equal parts or equal pieces. So they're all going to be the same. Okay. So when we're dividing, I'm going to actually just do an example here to go through some of the definitions. Let's say I have the number 25 and I'm dividing it by 5 to get the answer 5 as well. So what happens is your quotient is your answer. So that is the answer to a division problem. Your divisor is what you are dividing by. And then the other number is your dividend, like what you're starting with. Okay. So I guess this would be the number you are trying to break down. Okay, so again, that little hashtag means number as well. So you have your dividend, your divisor, and your quotient. Now, there are different ways that we can also write division. So let's do this example. Let's do 16 divided by 8 equals 2. So that's one way to write division. We can also write it like this. Okay, 16 divided by 8 equals 2. And we can write it like this. It should be 16. 16 divided by 8 equals 2, or sometimes we'll write the fraction a little bit slanted, so you may see it like 16 divided by 8 equals 2, like that as well. So these are all ways that we can write division. Here, this little bar is called a fraction bar. As well. Okay. So just different ways that we can write division. Now, I would say most times as we get further into the course, we'll be using those fraction bars a lot more. When we do long division, we're going to use this division bar instead. So that will be more helpful. All right, so just a couple quick examples. So for instance, 30 divided by 5. So we're saying how many times can 5 go into 30? And the answer here is 6. I could do 15 divided by 3. So how many times is 3 going to 15? It goes in 5 times. Or I could write 12 divided by 4, and 12 divided by 4 is 3. Now, again, to be able to get these answers, you do need to know your multiplication facts. So if you are having a hard time doing division, it's probably because you don't know your multiplication facts or your multiplication table. So I do suggest you kind of go, a lot of notebooks at the back of them have them, or agenda books, or just go online and search for a multiplication table and use that to kind of help you get started, so that you can figure out the answer, right? Because we are assuming that although we are running through how to do things like long division and multiplication by hand, we are assuming that you do understand the basic facts of multiplication and the basic facts of what division means here. So if you're struggling with that, let me know and I can try to help. So I want to do a couple more examples that kind of have to do with the value of 1. So for instance, let's say I did 7 divided by 1. Well, 1 goes into 7 times, right? Dividing by 1 doesn't change anything. Or 6 divided by 1 is still 6. If you divide a number by itself, so maybe 8 divided by 8, you also get 1. Or I can write this 15 divided by 15 is 1. So that number 1 is also really important here for division, like it is for so many other applications. So let's take a moment and define that property. So the division properties of 1. So the first division property of 1 is that the quotient of any number except for 0 and that same number is 1. So this is like our second example here. So for instance, 5 divided by 5 is 1. The quotient of any number and 1 is that same number. So this is like the first example I have up top here. Okay. So let's say I have 9 divided by 1 equal to 9. And we also have properties of 0 here too. So division, properties of 0. So the quotient of 0 and any number except 0 is 0. So what does this mean? Don't overthink it. You already know this. So if I take 0 and I divide it by any number, like 5, I get 0. Or if I take 0 and divide it by any number, like 7, I get 0. Or if I take 0 and I divide it by any number, like 9, I still get 0. So there is one thing to be careful about, though, and that's that the quotient of any number and 0 is not a number. We say it is undefined. So for example, 5 divided by 0 is undefined. 7 divided by 0 is undefined. And also 9 divided by 0 is undefined. So order is important here. This is not like multiplication or addition when we can rearrange the order, we can regroup, it doesn't matter. That is not true for subtraction, and it's definitely not true for division. When 0 is in the numerator, so it is on the top here, it comes first, it's on the inside, it's perfectly fine. The answer is just 0. If 0 is in your denominator here, so in the bottom, if 0 is your divisor, then this is bad. We cannot have this. That number is undefined. Okay, so 0 cannot be the divisor. Okay, so those are our important properties. And again, I think most of them you already know, but the big one that always mixes students up is the zeros. So if 0 is the divisor, that is bad. It is undefined. We can't divide by 0. So cannot divide by 0. Okay, then it's undefined. So we have to be really careful here. All right, so now that we actually have the rules out of the way, let's remind us how to do some long division. All right, so let's do an example here. Let's do 2,541 divided by 3. So this is the same thing as 3 going on the outside of the division bar and 2,541 going on the inside. You want to be really careful of the order. It's not always the biggest number goes inside. It is for now, but it won't be once we get to fractions and decimals. So whatever number is first goes on the inside. Now, we're going to do long division, and I'm going to show you a little tip that is helpful for people who struggle with long division. So that 3 on the outside, before you get started, you may want to make a multiples list of your divisor. So over here, I'm going to just make some tips. Okay. Now, if you're really good at your multiplication facts or your multiplication table, then you probably don't need to do this because you're going to be pretty good at long division naturally. But if you're struggling with those multiplication facts, then this is really helpful. It takes time up front, but then it's going to make everything else much easier. So you're going to take that 3 and you're going to make a multiples list. That means you're going to multiply it by 1, 2, 3, 4, 5, and so on. So you're going to take that 3. We're going to do 3 times 1, 3 times 2, 3 times 3. Now you can do this on your own, or you could take out your multiplication tables or something like that. And you only have to go through times 9, because whenever we're dividing our answer, at least one part at a time should never be more than 9. So you can make your multiples list times 9, or up through times 9. And my second tip is the phrase, does McDonald's make burgers really? So this is an acronym that just helps you remember the steps. And I'm going to show them to you as we go through. So your first thing, the does, stands for divide. So our first step is to go ahead and divide. And what you're going to do is do it one digit at a time. So does 3 divide into 2? It doesn't. 2 is too small. 3 cannot fit into 2. So what I like to do is I will put a 0 above it just to stay in order. You need to stay lined up when dividing. So 3 does not go into 2. Now I do 25. Does 3 go into 25? Yes, it does. So if I'm not sure, I'm going to look on the right here to my multiples list. I'm going to find the number that is as close to 25 without going over it, and I see it's right here at 24. So 3 goes into 25 8 times. The 8 goes up top, and the 24 goes underneath the 25. McDonald's stands for multiply. Oh, sorry, this should say subtract. Sorry, guys. Wrote it too fast. Does McDonald's, oh my gosh. Doesn't say subtract. It should say sell, which means subtract. I apologize. I'm losing it. Does McDonald's sell burgers, really? So this is the dividing part. It goes in 8 times. And then the multiplying part is the 24, because once it goes in 8 times 3 is 24, which we can also see here. After that, the sell part means that you're going to subtract. So we subtract what's left here. 5 minus 4 is 1. 2 minus 2 is just 0. And then the burgers stands for bring down. So you bring down just the next digit. So 1 digit at a time. And now we do the same thing again. So really stands to repeat the process. So we're dividing, we're multiplying, we're subtracting, and we're bringing down. We're going to do this over and over and over again until we're all done. So now I do 3 goes into 14. So again, if you're good with your multiplication facts, you may already know that 3 goes into 14 4 times, which is 12. But if you don't know that, you can see it over here. So 12 is as close as we can get to 14 without going over. So it goes in 4 times. I guess I'll use pink here. And then 4 times 3 is the 12. So we're going to subtract that 12. And I get 2. And I go ahead and I bring down my 1. Finally, 3 goes into 21. How many times? Well, it goes into 3 times 7 is 21 exactly. So it goes in 7 times. And 7 times 3 we said is 21. And when I subtract, I do get 0. Now there's nothing left to bring down. If I had a 0 and I still had numbers here, I'd have to still keep going. So, but there's nothing left to bring down. My answer is 0, so I am done. So 2,541 divided by 3 is 847. And if I have a 0 at the end, then it goes in perfectly even. I don't have to worry about any remainders here. All right, let's do another example. So 3,705 divided by 5. And again, I'm going to start by getting set up here. Now, if you're struggling with long division, I'm going to have you make a multiplication table of the number 5. So you do 5 times 1, 5 times 2. It does take a little bit of time up front, but once it's done, then your multiplication should be pretty, your division should be pretty quick because you have all your work already done. Okay, so I'm just writing my multiplication list out. So now I go ahead, I'm going to start. So 5 does not go into 3. Again, I'm just going to put a little 0 as a placeholder. 5 goes into 37. The closest I can get to 37 without going over is 35. So it goes in 7 times. And 7 times 5 is that 35. I subtract and I get 2. And then I'm going to go ahead and I'm going to bring down 1 digit. All right, 5 goes into 20 here. I go in exactly 4 times. The 4 goes up top, and then 5 times 4 is 20, gets subtracted out. Now my answer is 0, but I'm not done here because I have more digits. So I do have to bring this 5 down and keep going. 5 goes into 5 just 1 time. And now I have a 0, but I have nothing left to bring down. So I am done. So 3,705 divided by 5 is equal to 741. Now, I will make a note here that you can check by multiplying. And I'll just do it this one time. So what you can do is take these values here and multiply them. So do the 741 times by whatever you divided by, so 5. 5 times 1 is 5. 5 times 4 is 20, so 0, carry the 2. 5 times 7 is 35, plus 2 is 37. And you can see you do get that original number back out. So you can check your division. Okay. Now, I do also want to talk about the fact that you could get remainders here, right? So not every answer comes out to be perfectly even in the end, right? We don't always get a 5, so you kind of have to see what's going to happen. So let's try another example. All right, so let's do the same 3,705, but this time I'm going to divide it by 6. And again, I'm going to just start by making my multiples list. You don't have to do this. So if you're pretty good at division and you know your multiplication tables very well, then you really don't need to do this. But this is really helpful for students who are making a lot of mistakes, who really struggle with their multiplication tables. Again, it's worth it to go through it in the beginning and write those values down so you have them, and then you can just use that table all ready to go. Okay, so now I have 6 into 37 first, right? It does not go into 3, but it does go into 37, and I can go in here. I get 36 is as close as I get, so I get 6 times 6 is 36. And I subtract and I get 1. And I'm going to bring down one digit. I get 10. Now 6 does go into 10. It only goes in one time. 1 times 6 is 6. So I subtract and I get 4. I bring down the 5. And 6 goes into 45. Let's see, 42 is as close as I get, so that goes in 7 times. And I get 3. Now there's nothing left to bring down. Once we get to later chapters on decimals and fractions, we'll learn how to deal with this better. But for right now, what you do is you just write R3, and that stands for remainder, meaning that there is some left over. So 3,705 divided by 6 is 617, remainder 3. Okay, so it only goes in 617 times altogether, and you do have 3 units still left over. That's sort of like our extra. So if you had, let's say, I don't know, 3,705 candy bars and you had 6 friends, well, everybody gets 617 of them, and then there are 3 candy bars left over that you sort of can't split evenly as wholes. So you have a remainder there. All right, let's do another example, and let's make this one a little bit harder. All right, how about we do 1,279 divided by 24. So I have 1,279, I'm dividing it by 24. 24 goes on the outside. Now, 24 is a little bit harder to find the multiples of, but you can still do it. So if the multiples list is working for you, then you can start it out. Some of these you may be able to do in your head, like 24 times 2, you may be able to do that, that is 48. Okay, or 24 times 3 is going to be 72. So the first couple I can maybe do in my head, but after that it's going to get a little bit harder. So what you can remember though is that multiplication is just repeated addition. So notice that each time you go down the line here, all you're doing is adding 24. So you may find that helpful then to help complete your multiples list. So instead of multiplying each of them out, you could also just add, in this case, 24 each time. And fill in your chart that way. So I can just add another 24 here. And sort of just go on down the line like that. So if I add another 24, I get 144 and so on. Okay, so I'm going to just stop there for now. And I know I have a few more to do, but I'm going to see if I need them. So I'm going to do the first few and get started. All right, so 24 does not go into 1. 24 does not go into 12, but it does go into 127. And I do have my value here. So I know I can see 120, I see 144, which is too big. So 120 is going to be the best I can do. So it goes into 127 5 times. And 5 times 24 is 120. So I subtract, I get 7. I'm going to go ahead and bring down that 9. Now 24 goes into 79. Let's see, 72 is very close. That's as good as I'm going to get. So it goes in 3 times, which is 72. And I have a 5 left over. Now I have nothing left to bring down. So at this point, I'm going to stop and I have remainder 5. So my answer here, I don't need the leading zeros, is 53, remainder 5. Now the reason I do the leading zeros is to stay organized. Students I find make the most mistakes in division because they are messy or they try to scrunch the numbers together. So the other thing you could also do if you find it helpful is you could draw those vertical lines in kind of as you go down. You can see I even got a little bit off track there with that 9. So that could help as well. This is going to be really important when we get to decimals. So it is important to learn how to line up, particularly once we get to decimals. If you put your 5 here over the 1, then when we get to decimals, your answers are going to be very off. So start practicing now by lining things up. All right, let's do one more example because I think everybody needs practice on long division. All right, so let's do something a little harder. Let's do 12,543 divided by 260. Now, for this one, I'm not going to do the multiplication table list here because 260 is pretty high. That's going to take me a little bit of time. It works really nice for smaller numbers, but it can be kind of tough for large numbers. So I'm going to try to estimate what I think the answer is going to be and see if I can get close. So I'm going to start first. 260 does not go into 1. It does not go into 12. And it does not go into 125. So the first thing it goes into is 1,254. So I need to know how many times can 260 go into 1,254. So I'm going to have to guess here. And you can think of it by kind of estimating. So 260 is close to 300, right? I know it's a little bit smaller, but close to 300. And 1254 is kind of close to 1,200. I know I'm not rounding perfectly. I'm just kind of trying to get a ballpark. So 300 times 4 would be 1,200. I'm kind of thinking like that. So maybe try times 4 first. And what I'm going to do is I'm not going to write my answer in here. I'm going to do it off to the side. So 4 times 0 is 0. 4 times 6 is 24. 4 times 2 is 8 plus 2 is 10. So I see if I do it times 4, I'm at 10,040. That looks pretty good, but it looks kind of low. So I'm going to try times 5 as well. Here I have 30. 10 plus 3 is 13. So now I can see that 1,300 is definitely too big. So I know that 4 was the right option here. And 260 times 4 is 10,000. And I know some students like to multiply right here, and that's how I learned it as a child. I learned how to just guess and multiply right within the problem. I personally, as I got older, found that very confusing and messy. I'm always erasing and things don't erase well. So I like to do my multiplication off to the side. Try it first, see if I get close. If I'm wrong, then I don't have to erase everything. So I do recommend that to students is do it off to the side, take a guess. If you're not sure, try the next number up, the next number down, kind of see where you wind up. And now I'm going to go ahead and subtract. And I have 214. You do want to make sure when you subtract that this number is smaller than your divisor. So 214 is smaller than 260, so I know I did a good job. All right, and then we're going to go ahead and bring down that 3. All right, so now I need 260 into 2001.43. And I notice that my numbers here are pretty low, so I need to guess a lot higher. So I'm just going to take a guess here. I'm going to say, let's try times 8, right? Because times 5 is much too low, so I'm going to go up a little bit. 8 times 0 is 0. 8 times 6 is 48. 8 times 2 is 16. Plus 4 is 20. Oh, that looks really good. 2080, that looks really close, right? But still less than. But if I'm not sure, try the next number. Let's see if I can get closer. Here I have 54, 18, 19, 20, 21, 22, 23. So now I'm way over. So 9 was too big. So 8 must have been the right option. So I get 2080 when I multiply. And I'm going to go ahead and subtract. And I have 63. 63 is less than 260, so I know I've done the best I can. I have nothing left to bring down, so I have my room. So there is my answer for that one. So you can see long division is long. It does take some time, but I really do encourage you to do a lot of your work off to the side. I think it just makes it much cleaner and easier to follow. So the first strategy I focus the most on is the multiples list, because I think for most students, that's going to be really helpful for you just to see that list of multiples. Once it's written, you can go through the division quite quickly, comparatively speaking. When you get to numbers that start getting too high, though, at this point, you're going to be spending a really long time trying to write the multiples out, which is not what we want. We want it to take a little bit of time, but not too much time. So once you hit that, then maybe you're better off guessing. So try to guess, get in a ballpark. If you're not sure, try times 5, because that's right in the middle, right? So at least that way you know what numbers are higher or lower. Don't erase your work. I have so many students who erase their work and then they go back and they need it in the next part, right? So when I did the 4, I didn't erase my work because now I can use that work to see like, oh, well, those numbers are too low. Let me try higher. If I've erased it, then all my work is gone. So don't erase your work. Leave it off to the side, save it because it may come in helpful later on, okay? So another little thing just to kind of keep in mind, I'm not going to spend too much time on this, is that division is actually just repeated subtraction. So just like multiplication is repeated addition, division is actually repeated subtraction. So sometimes that really helps students to kind of process through how division works. So for instance, if I did something like, how about we do 10 divided by 5 is 2, right? So if I did 10 divided by 5 is 2, so we can do it 2 times. So this means that if I did subtraction, I would do 10 minus 5, which is 5, and then 5 minus 5, which is 0. So notice it took me 2 times to get down to 0. Or if I do 16 divided by 2 is 8. So I would do 16 minus 2 is 14. 14 minus 2 is 12. 12 minus 2 is 10. 10 minus 2 is 8. 8 minus 2 is 6. 6 minus 2 is 4. 4 minus 2 is 2. And 2 minus 2 is 0. And it took me 1, 2, 3, 4, 5, 6, 7, 8 times to get down to 0. So again, I don't want to spend too much time on this, but you can see that division really is just repeated subtraction. How many times would you have to subtract that number to get down to 0? So it does work very similar to multiplication in a lot of ways, or have a lot in common. Okay, so the last thing I want to do in this video is just talk about some applications here too. So one application here would be on averages. So an average is the sum of the numbers divided by the total numbers you have. So for instance, let's say I was taking a test and our test scores were 90, 85, how about 100, 60, and 75? And I want to find my average. Well, the first thing I need to do is add up those numbers. So I do 90, 85, 100, 60, and 75. Here, 5 plus 5 is 10, so I can carry the 1. 9 plus 1 is 10. Let's see, plus 8 is going to be 18. Okay, 18, sorry. Plus 6 is going to be, what, 24. And then plus 7 is going to be 31. Yep, and then here I have a 4. So my sum is 410. And then the total numbers I have are 5. I have 1, 2, 3, 4, 5. So now we do 5 into 410. 5 does not go into 4, but it goes into 41 8 times, which is 40. And then 5 goes into 10 2 times, which is 10. It comes out even. So our average here would be 82. So if you wanted to find your average of your test scores, let's say, then our average could be 82 in this case. There are some keywords as well for division. So obviously, the word divide, quotient. I'll say divide or divided by. Per also means divide. So sometimes we'll see things like miles per gallon. So that word per often means to divide as well. If you talk about equally sharing something or anything going into equal groups, then that also typically means division as well. One thing you do want to be careful here is that order does matter. Okay, so keep in mind that order matters. So if I say, for example, 10 divided by 2, that means 10 divided by 2, or 10 divided by 2, or 10 divided by 2. So you do have to go in the order that it is given. Or if I say the quotient of 10 and 2, again, that means 10 divided by 2, 10 divided by 2, and 10 divided by 2. So you just want to be really careful here with your ordering as well. So let's do one last example. All right. So let's say that the math department has some extra notebooks for students. They have 238 notebooks left and 19 students in the department. How many notebooks can each student receive? Okay, so here we have an idea where we have 238 total, and we're trying to distribute it equally among our students. Now, I know the word equally is not there, but it is implied, right? We don't want to give one student 5 notebooks and the other one 50 notebooks. That's not fair. So if we're trying to break something down into groups here, it's typically done equally. So we're looking at a division problem. So we're taking the 238 notebooks and we're dividing it by our 19 students. Okay, so I'm going to, again, do a little practice without the multiples list this time. And we're going to just take a guess. So first of all, 19 does not go into 2. 19 goes into 23. Now that hopefully is pretty obvious that it's only one time, right? 1 times 19 is just 19. But if I did 19 times 2, if you're not sure, here we have 18, carry the 1, so I'd have 38. That's going to be way too big. So it only goes in one time. And when I subtract, I get 4. 4 is less than 19, so I know I have the right value. And then I'm going to go ahead and bring down the 8. Now here, maybe I'm not as sure, right? 19 goes into 48. How many times? I'm not sure. So in this case, let's see, 19 times 2 was 38. And let's try 19 times 3. So that would be 27. 3 times 1 is 3, plus 2 is 5. So 57 is too big. So 2 is going to be my answer here. And I do have a remainder of 10. So what would likely happen is that each student would receive 12 notebooks. And there would be 10 notebooks left over. Okay, so maybe the department will hold on to the 10 notebooks and save them for next year, or maybe they'll reach out to students who maybe need more later on this semester or something like that. But for right now, if we're doing it equally, each student receives the 12 notebooks, and then there would be 10 left over that the department could hold on to. Now, one thing I do want to note is, how do you check something with a remainder? And you do check by multiplication. So you're going to start by multiplying your 19 by your 12 here. So 2 times 9 is 18, carry the 1. So 2 times 1 is 2 plus 1 is 3. I'm going to put my placeholder in. 1 times 9 is 9. 1 times 1 is 1. And I get 228. And then what you do is you add in the remainder at the end. So you're going to multiply. So now I have the 228. My remainder was 10. And you can see that you do get that 238 that you started with. So you can check problems that do have remainders. It's a little bit harder, but you do your multiplication first. So you're multiplying your answer by your divisor. Okay, so multiply the quotient times your divisor, and then you're going to add in your remainder afterwards, and that's how you can check.